Alright, so MES Note on Planck's constant. Planck's law was able to better predict blackbody radiation by modeling energy as discrete packets called quanta, which ushered the start of quantum, which ushered in the start of quantum mechanics. I had initially written up additional information on Planck's law and its derivation, and it was pretty extensive, but I have since removed it as it was too far off topic from the straightforward applied project. My initial reasoning was to compare the mainstream interpretation of Planck's constant of being a, quote, quantum of action with Lori Gardi's, a YouTuber over here, interpretation that it is in fact the quantum of, quote, energy. And the following links I recommend as reference for further research. So this is derivation of Planck's law by Physics Explained. It's a decent derivation of it. And I was, in fact, when I was writing up, I went pretty much step by step of the derivation that they had and included it in here. Then realized maybe just save that for another video. So then another reference that I recommend is so Cycles and Planck's Constant by Lori Gardi, aka Fractal Woman. And this is an Hive article that I wrote, and I put a bunch of links to her videos and paper over there, and also another article that I wrote referencing her paper and her notes is a modified unit analysis, and this is on the types of units, or the unit analysis that she does, and it basically includes the cycle. So whenever you have frequency or wavelength, she always includes the cycle, and then you get some very interesting interpretation that arises from this viewpoint. So anyway, so the derivation of Planck's law, just for a quick summary, the derivation of Planck's law involves quantizing energy, as an integer number and multiplied by Planck's constant h and multiplied by frequency f. And this is from the derivation video right here. So here's just a screen grab from it. So the birth of quantum mechanics. So energy is quantized according to Planck equals to n times a minimum increment, which is this epsilon. And then he determined that is equal to Planck's constant times frequency. It's related, so it's proportional to frequency. So n h f. And then this is the classical one, is just energy is you have infinitely continuous, so there's no discreteness. So you have energy at every decimal place. Just keep scrolling all the way up. And then the quantum one, you have energies either zero. This is the next one is going to be hf. Then the next one's 2hf, and the next one's 3hf, 4hf. So it depends on the frequency. The use of the frequency term in the quantized energy equation is interpreted as the usual, quote, wave particle duality photons with different discrete energies. So, for example, if you have E equals hf, so that's that is the minimum energy for each frequency. So then you're going to have different types of quote photons or photon particles. And so you're going to have one with a wavelength that's different than this one. Another one is different than this one. But then you're going to have the amount of energy is going to be that h constant times the frequency. So you're going to have a bunch of different shapes over here. So this one's long, this one's short. This one's the long wavelength, but you're going to have a quanta of that. Then you multiply the integer value to get total of them. And then here's also the wave particle duality picture. So you have a wave, you have a particle, and there's the wave in there, and then you basically quantize it. But there's an interesting aspect that I didn't realize until I came across Lori Gardi, aka FractalWoman's YouTube channel, which has some pretty interesting insights. So the physics investigator, it's a good term, Lori Gardi argues that since the frequency term has units of cycles per second, then the conventional quantized energy equation is actually for a single second or unit of time. Because remember, it's cycles per that second. So if the frequency has frequency 10 per second, then there's that unit of time that's in there. This means that instead of quantized energies for each frequency, because if you're using a different unit of time, for example, instead of seconds you use hours, you're going to have a different frequency term. So then, in other words, frequency is not a fundamental, or you can view it as not a fundamental thing. So instead of quantizing, let's say if you have a high frequency, you're going to quantize this one, it's going to be a different shape than this little tiny one. So going further, don't read this again. So this means that instead of quantized energy for each frequency, instead light may be viewed as being made up of a single quantized energy, and this would be Planck's constant, which corresponds to higher total energy for each second or unit of time. Or actually, instead of writing the layout, so it's a higher total energy for each, or actually, a better way, I just rewrote that sentence. So let's read this again. So this means that instead of quantized energies for each frequency, instead light may be viewed as, light may be viewed as being made of a single quantized energy, Planck's constant. Thus, the more quantized energy units per unit time corresponds to a higher total energy. So yes, if you have, this is from our paper, so figure 1, 3 different wavelengths or / frequencies of light. So here's a unit of time. So if you have a lot of these quantized energies in there, this is going to be higher energy and higher frequency. And then in this unit of time, this can be lower frequency, but you're going to be at lower energy. This is super low frequency, but again, each one of these is exact same energy as this. These ones are all exact same. So a high energy quote photon. So instead of circling all these as a photon, so this would be mainstream physics would be like this is a high, this is a high wavelength, low frequency photon, and this is another photon, and this is another photon. This is a different wavelength and different frequency. So instead of that, Lori Gardi says no, it's actually they're all made of the individual discrete energy units. And then when you have this unit of time there, that's where you get the frequency, and basically the more of these that are compact in space and time, then that's more energy, less energy. So in this interpretation, the frequency is an emergent or more abstract concept made up of many quanta of energy. Yes, it's made up of many of these. I'll be exploring this further, so stay tuned. It's pretty fascinating stuff. This might be key to a lot of things.